Hello everyone, welcome to Mathematics Method Unit 1. This video will focus on 6a, factorization of the polynomials. The learning intention of today is using the factors theory to factorize polynomials. Success criteria, the first one is that I can describe and apply remainder theory. And the second success criteria is I can describe and apply factor theory to factorize the polynomials. Okay, so now let's have a look this example. So this example, I already wrote the non-division. Over here you can find this non-division on your booklet as well. So we have x cubed plus 3x plus 2x plus 1. That's my dividend. This is divided by my divisor x minus 2. Alright, and then I have a quotient x squared plus 5x plus 12. That's and then at the last we have remainder, which is 25. Okay, so now I would like to show you something interesting. Okay, so now I know my polynomial function of the dividend, okay, is equal to x cubed plus 3x plus 2x plus 1. That's my dividend. I just let it equal to p of x. Okay, so p stands for function polynomial, polynomial function of x. Okay, so now I'm gonna do, so my divisor is x minus 2. Okay, so I'm gonna let x minus 2 equal to 0, and then if I solve out for x will be equal to 2. Okay, so now I'm gonna substitute x is equal to 2. I'm gonna substitute x equal to 2 back to my p of x, which is my dividend. Okay, so now p of 2, so now that will be 2 to the power of 3 plus 3 times 2, okay, because here is 3x, then plus 2x, so that will become plus 2 times 2 plus 1. Alright, so if I solve it out, you see here, that will be 8 plus 6 plus 4 plus 1 equal to 25. And then you see that 25 is actually my remainder. Okay, so now you see this is actually part of our remainder theory. So go back to our booklet. You see here remainder theory. If p of x, that's my polynomial function, that is my dividend as well. If p of x is divided by beta x plus alpha, okay, that's my divisor, the remainder will be p of negative alpha over w. Alright, so you're probably wondering where is this coming from. Alright, so then it's same with just like what we did here, because this is my divisor, so this is my divisor. So if I let x minus 2 equal to 0, and then x will be equal to 2. Okay, same for my remainder theory, because this is my divisor, and then I just let beta x plus alpha equal to 0, and then you see here, if I move alpha to the right hand side, beta x will be equal to negative alpha, and then I'm gonna divide it by beta on both sides, and then that cancels out, x will be equal to negative alpha over b. That's where this one, negative alpha b, coming from. So then after you get this one, you substitute this negative alpha over beta back to your polynomial function, which is at a dividend, and then if you get the number that you get, that is your remainder. Okay, so now let's have a look about example 9. P of x, that is divided by x minus 2. Okay, so x minus 2 is my divisor, so I'm gonna let divisor x minus 2 equal to 0. Okay, so in this case x will be equal to 2. Okay, so now if I substitute x is equal to 2 into my polynomial function, and then I'll have 2 to the power of 3 minus 3 times 2 to the power of 2, and then here we're going to continue to do plus 2x. Okay, so plus 2x, x is 2, so plus 2 times 2 and plus 6. Now if I simplify, I'll get this is 8, this part is negative 12 plus 4 plus 6, and then it will be equal to 6. Okay, so that 6 is remainder. Okay, so therefore remainder is 6. All right, so let's do another example. Now, my p of x dividend is equal to x cubed minus 2x plus 4 is divided by 2x plus 1. Okay, so divided by 2x plus 1, so that's my divisor. So we're going to do the same thing. Let 2x plus 1 divisor equal to 0. Okay, so then solve out for x. Then 2x is equal to negative 1. X is equal to negative 1 over 2. Okay, so negative half. Alright, so now I'm going to substitute negative half back to my polynomial function. Alright, and then we'll have here x cubed will become negative 1 over 2 cubed, and then we have minus 2 times x, so minus 2 times x, x is negative half plus 4. Alright, and then if you simplify, you will get 39 over 8. So therefore, remainder is 39 over 8. Okay. Now let's have a look at example 10. Example 10, we have p of x equal to x cubed plus 2x plus 8 is divided by x minus 2. Now this question, we told you the remainder is 4. Okay, find the value of a. So we can still use that remainder theory, okay? Because p of x is divided by x minus 2, so we can just simply let x minus 2, the divisor, equal to 0, then x is equal to 2. And since we know remainder is 4, so we know if I substitute x is equal to 2 back to my polynomial function, I'll get the answer. The answer will be equal to 4 according to the remainder theory. Okay, so now I'm going to do the same thing, because p of x is equal to x cubed plus 2x plus 8. So I'm going to try substitute when p of x, p of 2. Okay, so that is the when x is equal to 2, I substitute back into the equation. So now that will become 2 to the power of 3 plus 2 times 2 plus 8. Alright, and then we know this remainder is 4. Okay, so it is equal to 4, and then I simplify this. 2 to the power of 3 will be equal to 8 plus 4 plus 8 equal to 4, and you can, that is 12 plus 8 equal to 4, and then a is equal to negative 8. Okay, so now let's have a look about the notes on the right hand side. Here, this is the example that I got from your exercise example 5 of 3b section 3b. Okay, so I have dividend x cubed plus x squared minus 14x minus 24. That is divided by my divisor x plus 2, and I got a quotient x squared minus x minus 12. Okay, that's my quotient, and now I get a 0 remainder, so there's no any remainder. Okay, in this case we say x plus 2. So okay, let me write it. Rewrite it. So x squared plus x2 minus 14x minus 24, that is divided by x plus 2. Okay, so this is equal to x squared minus x minus 12. There's no remainder. So this means this dividend can be divided by x plus 2. In this case, we say x plus 2 is a factor of the polynomial. Okay. So now we can still try. Let's have a look. If we do the same thing that is similar with the remainder theory. We let x plus 2, because x plus 2 is the divisor, so we let x plus 2 equal to 0. Then solve out for x will be equal to negative 2. Okay, I'm going to substitute back into my dividend, okay, because my dividend p of x is equal to x squared plus x cubed plus x squared minus 14x minus 24. Okay, I'm going to substitute that x is equal to negative 2 back to my polynomial, and then p will be p of negative 2, okay, because I'm going to substitute x is equal to negative 2. Okay, so that will become negative 2 cubed plus negative 2 squared minus 14 times negative 2 minus 24. And then if you solve it out, you will see it is actually equal to 0. Okay, so now here is the so if you have a look my booklet on my left hand side, so this is actually my factor theory. Okay, so now let's compare the remainder theory and the factor theory. Okay, so let me write the remainder theory over here again. Remainder theory, and we know when remainder theory is when p of x, which is the dividend, is divided by beta x plus alpha. The remainder is when we substitute negative alpha over beta back into our dividend. Okay, and the result that you got, that's your remainder. Alright, but for the case over here, we just did for example 5 that I show you, and we do the same thing, and we substitute p equal to negative 2 over here back to our dividend, and you actually get a 0. Okay, so now, factor theory. So this is our factor theorem. When px is divided by beta x plus alpha, all right, then if you substitute this negative alpha over beta back to your dividend, if you get some numbers, that's your remainder. If you get it is 0, if it is 0, that means beta x plus alpha is a factor of polynomial of x. All right. In other way, if beta x plus alpha is a factor of polynomial of f, p of x, then we can substitute negative alpha over beta back to our equation. That will be definitely equal to 0. All right. Now let's have a look. Let's use an example to show to help you to understand a bit more. Okay. So if we go to your example 11. Okay. If we go to example 11. Now we say we have. The example asks you to show, okay, to show that x plus 1 is a factor of x plus 3, x to the power of 3 minus 4x squared plus x plus 6, okay? So we want you to show that this is a factor. So if you have a look about my notes on the right hand side. Factors theory. Okay, if beta x plus alpha is a factor, okay, if it is a factor, then you substitute negative alpha over beta back to your dividend will be definitely equal to 0. Okay, so now we can just try. So we let x plus 1 equal to 0, so then we can solve out x is equal to negative 1. Okay, so we're gonna substitute that like x is equal to negative 1 into our polynomial function. All right, so now we know p of x is equal to x cubed minus 4x squared plus x plus 6. All right, so now I'm gonna substitute x equal to negative 1 back to my equation, which is also a polynomial. Okay, so then it will become negative 1 cubed minus 4 times negative 1 squared plus negative 1 plus 6. Okay, and you simplify, it is actually equal to 0. Okay, so therefore p negative 1 is equal to 0. All right, so basically what we're trying to say is, okay, what we're trying to, let me use a different color, you don't have to write this. Basically what we're trying to say is p negative alpha over beta is equal to 0. That's what we just did. Okay, so this is equal to 0, therefore x plus 1 is a factor of x cubed minus 4x squared plus x plus 6. All right, so now we finished the first part, and let's read the question again. And hence, after we show that, hence find the other linear factor, okay, so now what you need to do is you need to do the long division, okay, because we will have dividend x cubed minus 4x squared plus x plus 6. Okay, this is divided by x plus 1. Okay, because this is divided by that. All right, so now we're gonna try to use the non-division, and then because this is two terms, we're gonna consider the first two terms as a whole, and the highest power term of your dividend at this stage is cube. Okay, so we use x cubed divided by x, which is the highest power or power term of your divisor, and then you get x squared. Okay, so I'm gonna put that x squared over here. So now x squared times x give me x cubed, and then I'm gonna use the second term of your divisor, plus 1 times x squared, then you get a plus x squared. Okay, and then I do subtraction, x cubed minus x cubed cancel out, and you get, and then you have negative 4x squared minus x squared over here. Okay, so then you get negative 5x squared. Okay, since our divisor is two term, I'm going to bring one more down to give me two term again, and then you're going to do the same thing, highest power term for at this stage negative 5x squared, that's the highest power term, divided by highest power term of your divisor x. Okay, so then you get negative 5x. Bring that negative 5x over here, and then we can start it to time them together. X times negative 5x give me negative 5x squared. And then I do 1 plus negative 5x give me negative 5x, and then subtraction, and then that cancels out, then x, okay, so x over here minus negative 5x, okay, it's negative 5x, then you'll get x plus 5x equal to 6x. Okay, so now I can put 6x over here, and then I can rub this off and continue. I can bring that 6 over here, so that plus 6. Okay, and then I'm going to use the highest power term 6x divided by my highest power term of the divisor will be, okay, you'll get 6, so put that 6 over here, so then you have 6 times x, 6x, 1 times 6, you get 6, and then it is equal to 0. Okay, so therefore I can write x cubed minus 4x squared plus x plus 6, okay, will be equal to my divisor times quotient x squared minus 4x plus 6. Okay, so you are not finished this question yet because we are asking you to find the linear factor. So this one, x plus 1 is linear, but this one is quadratic, is not the linear yet. So you need to factorize your quadratic x plus x squared minus 5x plus 6. Okay, so that is something we did before in chapter 3b. Okay, so then you'll have x plus 1. If you factorize this one by using the method that we learned before, and then you'll have x minus 2 and x minus 3. Alright, if you don't know how to do it, check the video that I made 3b, how to factorize quadratic. Okay,